We take up a next question. Now there are 4 friends and 10 hotels. In how many ways can 4 friends can stay in 10 hotels? That's the question. In how many ways can 4 friends can stay in 10 hotels? There is no restriction here given. That means what? All the 4 people can stay in any of the hotel, or same hotel they can stay. 2 can be in one hotel and 3 can be in another hotel, 1 can be in another hotel, or all 4 can be in different hotels. Various possibilities can come. There is no restriction. Therefore here the hotels are the one which is receiving the friends. Therefore your n is equal to 10 and r is equal to 4. So therefore it will come out as 10 raised to the power of 4. This gets the answer for this particular question. Now in this, if I am looking at what are the various possibilities which we get in this, what are the various possibilities in n raised to the power of r? Like typically in the letters in the post office problem, whatever cases we get, here also we get all the 4 cases. What are the cases? We'll write down. Number 1, all 4 together. All 4 together. This is one case we can get. That means what? If all 4 are together, that means one hotel they are occupying, all the remaining hotels are empty. Then the second case we can get all 4 in different hotels. All 4 in different hotels. This is another case we get. Third case, 2 together they stay in one hotel plus 2 together. That means what? 2 hotels are occupied, remaining 8 hotels are empty. Third case. What is the fourth case we can get? 2 together and 2 in different hotels. Here in this case, there is 1 hotel and 2 hotels. 3 hotels are occupied, remaining 7 hotels are empty. There can be a fourth case, fifth case. Alright, 3 together and 1 in a different hotel. 2 together and 1 in a different hotel. So all the cases, whatever are possible, we are considering. If you individually calculate and add all of them, it should be equal to a 10 raised to the power of 4. Now here, when we are putting the people into a hotel, there is no question of, like, for example, dividing them into parts and putting it. Suppose, for example, if I take the same question as, say, 4 apples, right, and 10 people. 10 people. Now here, the apple can be cut and divided among the people. That means what? I can make them into 10 pieces, make them into 100 pieces, make them into 1000 cases. Whatever I want, I can do it. I can give the apple as a whole. If I give apple as a whole, there will be many people without any apples. Whenever we are dealing with apple kind of questions, we talk as apples being identical and not identical. That we will be discussing in the end of the what you call chapter. But as of now, we deal only with people where they are different people. The identical objects will not be dealing in initial stages. But here, apple and people, typically if you look at, it is not going to be 10 raised to the power of 4 formula, because apples can be cut into pieces and then given. Even if it is not cut also, apples not identical if you consider, then the answer can be 10 raised to the power of 4. Otherwise, this particular idea we will be discussing in the end. That means that's the last concept we will be discussing. But just for an understanding, I gave you that particular question. Don't write it as 10 to the power of 4 when it comes to apples and friends. Is this clear? So these are the total number of cases which we got. And individually, if you take out and add all of them, and that gets 10 raised to the power of 4. Now in this, I can put restrictions and solve questions one by one. So we'll take up in the next question, with restrictions, the kind of questions what we get in this hotels and friend problem. We'll go to the next problem.